Amazon has been asked this question in the interview. We are given the head of a single linked list and we need to reorder the list into the following. The way we are reordering is to split the list into half, and we are looking for the second part. After it's been sorted, we need to reinsert into the first part. That results into 1, 4, and then 2, 3. For the second example, it's the same procedure. We find the middle node of the whole list, and we split the list node into half. We reorder the second part to be descending order, and then we are reinsert into the list nodes. Therefore, we can break this question down into 3 different parts. The first part is to find the middle point and split into 2 sub-list nodes. Because we are talking about a single linked list, this is not like the array that it has the end, middle, or the first. At a single linked list, we are always dealing with the head. As the head moving to the end, if we are just looking for one pointer here, we are not sure if it goes to the end, middle, or the earlier. So we need at least 2 pointers. Let me introduce the first one. It's called the slow pointer, that it goes step by step to the next. And there is another pointer called fast. It jumps 2 steps at one time. So initially, the slow and fast pointers, they are all pointing to the first element. As the slow goes to the next, the fast will jump 2 steps, so it reaches to the third node. And then as the slow goes to the next, the fast jumps 2 steps to the next node of node 4, which is none. Therefore, we terminate the while loop, and the slow pointer is actually on the middle. And here's the Python code. It is very straightforward. Notice that the if statement inside the while loop is the first one we need to check if the fast is not equal to none. And the second one we need to check if the fast has the next step. Because if we are making 2 steps jump, we only care about the first point if there exists, and the second point if there exists. So if we put the check mark at the first point and the second point, we're guaranteed that we can make the jumps to the third point. After we finish the part 1, we're moving to the part 2. We need to inverse the middle points, so the list node becomes points from the right to the left. Let's introduce 3 pointers. One is called the temporary, one is called the previous, and one is called the list2. List2 is initially at the head node. The temporary variable is to ensure that we are moving to the right until the end of the list node. At first, let's just assign the temporary variable to the next of the list2, because after the inverse, the first point that is node 3 will become the last point, which connects to the none. So we need to modify it, the next of node 3 to be none, which is initially by the previous variable. And let's delete the original connection. We need to reassign previous variable to current list2, and then we move list2 to the temporary variable. And here's the Python code. So eventually we'll inverse the middle. That results into pointing from the right to left. Finally, we are on the part 3 that we need to merge 2 list nodes. So our goal is to merge in list 2 into list 1. From the second part, we know that the previous variable is referring to the inverse middle. So I'm going to rename this into list 2, just to clarify. We also need to introduce the temporary variable. At first, let's assign the temporary variable to list1.next, because we are ensured that list 1 is moving to the right. And then we assign the list1.next, it's pointing to list 2. So the original connection is being deleted. And then we reassign the list 1 to a temporary variable to ensure it's moving to the right. Now we need to reassign the temporary variable to be the next of list 2, because we are also ensure the list 2 is moving to the right. So this is gone. And then we are pointing the temporary variable to the list 2 next. And we need to assign the list 2.next to be list 1. So we get rid of this. And then list 2 will move to the temporary. And eventually this will link all the nodes together. And this is the Python code for the part 3. And this is the Python solution for this question. You can pause here for a little bit to understand the part 1, part 2, and part 3. In the previous approach, it is very easy to mess up because we are dealing with so many pointers such as previous, temporary, and the current pointer. And now let me introduce an alternative way to solve this question. It's called recursive function with array. So when we are dealing with the list nodes, it is always easy that we can break the nodes into the array. And let's solve the question from the array. So by traverse all the nodes, we can break them down into one array. Let's looking for this subarray that's starting from the second element. Let us introduce the left point and the right point. And we realize the goal of this question is to reorder from the left and right. So we can append the right pointer first. So this is right and this is left. And we need to move the left pointer to the right and right pointer to the left. And we append the right first and then left to the result. And this is the Python code for the recursive function. We have two base cases here. The first one, if left is greater than right, that means this is an invalid function call, so we do nothing. If they're equal, this will happen in an even array, that the array has even length. So we just need to append one of them, so I just choose right to append. Finally, we can restructure the array into the list node. We can traverse the element for the array, and we can recreate the list node by giving the value. If you like this channel, please click like and subscribe. Thank you.